Hello students, hello and welcome to this video. In this video we will solve question number 31 to 40 of binomial theorems and expansions. The link to download the PDF will be in description, as well as at the end I will show you how we can download from the website and maintain an updated copy. I will also show you my website where you can come and ask questions related to class 12 mathematics, and I'll try to solve those questions which you have or answer those questions. So without further ado, let's get started. Now the thing is that question 32 has like 8 parts. So we might not go all the way till 40. We might uh, end the video by say question 35 or so. So question 31 says that if x to the power p occurs in the expansion of x square plus 1 upon x raised to the power 2, and show that its quotient is 2n factorial divided by 4n minus p upon 3 factorial times 2n plus p upon 3 factorial. So general term is given by, or rather rth term is given by 2n cr minus 1 x square to the power 2n plus 1 minus r upon 1 upon xr minus 1. Now, since the term contains x raised to the power p, we have 4n plus 2 minus 2r from this is minus r plus 1 from this is equal to p. So r is equal to 4n minus p upon 3 plus 1, and thus the coefficient is 2n factorial upon 4n minus p upon 3 factorial times 2n plus p upon 3 factorial. Question 32 says that find the term independent of x in the following binomial expansion. The first one is x plus 1 upon x to the power 2n. So we see that it is symmetric, so middle term will be free of expansion, or rather x. So we evaluate the rth term here, which is 2n cr minus 1 x raised to the power 2n plus 1 minus r divided by 1 upon x raised to the power r minus 1. So we add the power of r to be 0, power of x to be 0, and we get r is equal to n plus 1, and thus the coefficient is 2n cn, that is 2n factorial upon 1 n factorial square. Question 2 is part, or rather sub question 2 is 2x square plus 1 upon x to the power 15. We follow similarly. Now the power, the term would be, rth term would be 15 cr minus 1 to x square raised to the power 16 minus r 1 upon x raised to the power r minus 1. We add the powers of r, we get 32 minus 2r minus r plus 1 is equal to 0, that is r is equal to 11. So the coefficient is 32, c 15, 15 c 10. Third question is the expansion given is square root of x plus 3 upon 2x square raised to the power 10. So general term would be 10 cr minus 1 square root of 3 upon 3 raised to the power 11 minus r times 3 upon 2x square raised to the power r minus 1. So power of x in this question, in this term is 11 minus r upon 2 minus 2r plus 2, so r is equal to 3, and therefore the coefficient is 5 upon 4. Question 4 is expansion is 2x square minus 1 upon x raised to the power 12. So our rth term becomes 12 cr minus 1 to x square raised to the power 13 minus r times 1 upon x raised to the power r minus 1. So sum would be 26 minus 2r minus r plus 1, that is r is equal to, the sum would be 0, so r is equal to 9, and coefficient is 12c 8 times 2 raised to the power 4, that is 7920. So if there is any calculation mistake you find, let me know and I'll update it. Question 5 is 2x square minus 3 upon x cube raised to the power 25. So again, the general term is 25 cr minus 1 to x square raised to the power 26 minus r times minus 3 upon x cube raised to the power r minus 1. Sum of powers of x is 52 minus 2r minus 3r plus 3 is equal to 0, so r is equal to 11. And coefficient is 25 c10 times 2 raised to the power 15 times 3 raised to the power 10. 6 is x cube minus 3 upon x square raised to the power 15. So general term is 15 cr minus 1 x cube to the power 16 minus r minus 3 upon x square raised to the power r minus 1. Sum of powers of x is 48 minus 3r minus 2r plus 2 is equal to 0, that is r is equal to 10. So coefficient is minus 3 raised to the power 9 times 15c, 9 here. There should be 9, not 0. Okay, that's a mistake I notice. 7 is x square minus 3 upon x cube raised to the power 10. Again, TR is 10CR minus 1 x square raised to the power 11 minus r times minus 3 upon x cube raised to the power r minus 1. And now the sum of powers of x would be 22 minus r, there should be 2r here. Another mistake. Minus 3r plus 3 is equal to 0, so r is equal to 5. And this coefficient is 3 raised to the power 4 minus 10 raised to the power 4. 10c4. Okay. Last question is of this particular question. 1 upon 2 x raised to the power 1 upon 3 plus x raised to the power minus 1 upon 3 to the power 8. So we see that powers of x are symmetric. Okay, therefore the middle term, that is fifth, ninth terms are there. So fifth term would be independent of x. So we get r is equal to 5, and fifth term is 8c4 times 1 upon 2 raised to the power 4 is equal to 35 upon 8. Next question is, if there is 33 number, if there is a term independent of x, x plus 1 upon x squared to the power n, show that it is equal to n factorial divided by n upon 3 factorial times 2n upon 3 factorial. So proceeding like previous questions, we have the general term ncr minus 1 x raised to the power n plus 1 minus r upon times 1 upon x square raised to the power r minus 1. So sum of powers of x is n plus 1 minus r minus 2r plus 2. So r is equal to n upon 3 plus 1. And therefore the coefficient is nc n minus 3. That is n factorial divided by n upon 3 factorial times 2n upon 3 factorial. Question 34 says that prove that in the expansion of 1 plus x raised to the power m plus 1, coefficient of x raised to the power m and x raised to the power n are equal. For all m n greater than 0, m and n are in the set of natural numbers. So the pth term is given by m plus n cp minus 1 x raised to the power p minus 1. Now assume that it contains x raised to the power m, then p is equal to m plus 1. And coefficient is m plus n cm. Now let's say that rth term contains the nth x raised to the power n, then that would be, here it will become r is equal to n plus 1. So the coefficient will be m plus n cn. And we know that m plus n cm is equal to m plus n cn. And thus we have proved this. Question 35 says that prove that in the expansion, sorry, this is not 35. 35 is, give that the fourth term in the expansion of px plus 1 upon x raised to the power n is 5 upon 2, find n and p. So fourth term we find, which is nc3 px raised to the power n plus 1 minus 4 times 1 upon x raised to the power 3 to the power, this should be 3, right? No, it is 1 upon x cube, so that's fine. Now since the term is independent of x, we have n minus 3. Minus 3 is equal to 0, so n is equal to 6, and the sixth term is 5 upon 2, so p is equal to half from this. I think we can stop here, and in the next video we will solve question 36 to 40. Okay, I don't want to solve a lot of questions because these days the attention span of students is quite short. So let me show you my book. You can come to my website testavoc.org. You can click the second, third and fourth links, which are algebra, trigonometry and coordinate geometry. When you download, there will be no date in the PDF, so you need to add date to the PDF, because I cannot put date in the PDF. The reason is, if I start putting date in the PDF, every time date changes, all other links will become invalid. The YouTube description will be invalid. If somebody has shared the link, that will become invalid. So it's not possible for me to add the date. And after 15 or 30 days, you should come and check if the book has been updated. Like algebra was updated on 2nd July, So you should come and check if the book has been updated, and if it is updated, you can download again and update the date. Also, I said the question answer website, so you can click on question number 8, link number 8, and you will come here. You can come make a login here and ask questions. There are some tags I have created for you: algebra, calculus, coordinate geometry, geometry, probability, and trigonometry. So you can ask questions related to these topics to me. And how to use the editor is, there will be a help button. So if you click that help button, question mark button is there. If you click that link button, then it will come to markdown help, and you can read this on how to actually edit the question, and login and other things are very trivial. So with this, I will take my leave here, and we'll meet again in the next video tomorrow, where we will solve question number 35 to 36 to 40. Okay, we'll solve these many questions. So we'll meet again tomorrow, and you have a nice day and keep learning and enjoy.